Hello friends, welcome to my YouTube channel Easy Aviation. Here we discuss about the short simple topic about the aviation field. Today's topic of discussion is that why a metal turns into red color when they are being heated. So I know this is not an aviation related topic, but it's a bit technical and I'll be giving the exact reason that why a metal is showing this property or getting into this color range when they are heated at a very high temperature. So to understand that, first we need to understand about the electromagnetic spectrum. Electromagnetic waves are the waves which are having both the component electrical and magnetic. They are the disturbance into the space, and they propagate at a speed of 3 into 10 raised to the power 8 meter per second with the speed of light. And anybody above absolute temperature, which is 0 degree Kelvin, they radiate energy or the electromagnetic radiation. There are two ranges which we need to focus on to explain this topic. First is the visible range and second is the IR range. Visible range extends from 0.45 micrometer to 0.7 micrometer, and from 0.7 micrometer to 100 micrometer is the IR range. Our visibility restricts in this wavelength only, where 0.70 micrometer is the red color and 0.45 micrometer is the violet color. Red is having the highest wavelength as compared to any other color, and that's why I use for the alerting system. This higher wavelength can be visible from far off distance, that's why used for alerting. Violet you could have seen in the day-to-day life, they scatter a lot. If you see a blue light, it will scatter, and this is scattered because of the particles which is available into the atmosphere, and because of that this wavelength is matching to that, and that's why it's scattered. So this is a general idea which I am giving about the visible light. And IR, you cannot see IR, this wavelength, but you can feel it in the form of heat. So that's an explanation for the IR. So this will remains the foundation to explain it further. So coming to the topic, we need to understand the Wein's law. Okay, so there is a very important concept. Any body, let's say body A, at temperature T degree Kelvin is radiating a mixture of wavelength lambda T, lambda total. Lambda total will be the summation of lambda naught plus lambda 1 plus lambda 2. There are multiple wavelengths, and then there will be one lambda which will be the maximum amongst all. So Wein's law explains the relation between this maximum lambda which is being emitted from the body with the temperature of the body. Understood? So wavelength at which black body emits radiation with maximum intensity, that is lambda max in micrometer, is inversely proportional to the temperature in Kelvin, and there is a constant 3000 micrometer. So this is the formula. So using this formula, let's make a chart here, which is both at one end will take temperature and second end will take the wavelength. So temperature is in the Kelvin and wavelength in the micrometer. So let's say temperature 27 degrees centigrade, which is 300 Kelvin. The wavelength, if we put 300 Kelvin into the formula, the wavelength which is coming out will be 10 micrometer. And if we increase the temperature to 3000 Kelvin, the wavelength will come out as 1 micrometer. I hope this much is understood, and this is what this curve is showing. As the temperature increases, the wavelength of the maximum of the black body spectrum shifts to shorter wavelength. Shorter, that's means 10 micrometer to 1 micrometer it has come, and if we further increase the temperature, the wavelength will further reduce. I hope this much is clear. This is another chart which is showing the shifting of lambda max from higher wavelength to lower wavelength as the temperature is increasing. So at 2500 Kelvin, the lambda is somewhere 1.15 micrometer. At 3000 Kelvin, it is 3000 Kelvin, we have already calculated, is 1 micrometer. And 3500 Kelvin, it is somewhere 0.85 micrometer. So if we conclude this explanation, as the temperature is increased, the lambda max value is the maximum wavelength is reducing and coming near to the red color or red wavelength. So that's why if a body A metal, if it is increasing, if the temperature is increasing, the wavelength will reach to the lambda max which is coming out will reach to the red color, and that is the reason why the metal will start appearing red initially and then go towards the yellowish or orangish color, which is at the farther range in the electromagnetic spectrum. So I hope I have made it clear. There is a chart which is showing at 600 degrees centigrade, this will be the color, and as we increase the temperature, it will go towards the yellowish color. So in conclusion, every body which is above absolute temperature emits radiation in electromagnetic, generally in the IR range, and when a metal is heated, the emitted radiation which is initially in the IR range shifted into the visible range. A very important point which I need to add is, since it is the spectrum and then there is a lambda max value and there is a spectrum of the wavelength which are being emitted. So once the body is heated, body A which is heated to some temperature T degree Kelvin, and the wavelength which is coming out reaches to, let's say, the center of the visible range. Visible range starts from 0.4 micrometer to 0.7 micrometer, and let's say at some temperature the lambda max is somewhere 0.6 micrometer. There is a spectrum of the wavelength which is being emitted from the body, and the mixture of the spectrum in the visible range gives you a white color. So the body will never reach to the bluish color. Yes, if a body can sustain a very high temperature and if it is shifting to the ultraviolet range, it might appear blue, but a normal metal, a normal alloy, if it is being heated and reaching to somewhere this lambda max value, the body or the output or the radiation will show the body in a whitish color and not in the red color or the blue color. So I hope this is an addition to what I had explained, and I think I have made it clear. If you have any specific query to this specific video, please let me know in the comment section. If you want me to cover some another topic related to aviation or some technical, please let me know. Please spread the news. Please send my channel to your family and friends. Subscribe or let me know if you have any other query. Here I sign off.